Okay, for topic two, we're going to talk about something called the standard deviation, okay? Now, in general, we're talking about measures of dispersion. In the previous video, we talked about the range, which is super, super easy to calculate. Remember, measures of dispersion just are asking like how spread out is your data. And the range is kind of, it's a really rough but very easy estimate for the spread of the data. It just takes the highest data item and the lowest data item and you subtract, okay? Standard deviation is much, much, much more involved, and it has a very wacky looking formula, but if you can understand the pieces of the formula, it won't be so bad. So first, let's define standard deviation. So the standard deviation of a data set is a measure of how spread out the data values are in relation to the mean. So we're very much looking at how spread the data values are when we're comparing them to the mean. Okay, the mean being the average. Okay. So it says it measures the average distance of the data items from the mean, showing how tightly or widely the data values are spread. Okay, so what we're going to do is we're going to let S equal standard deviation. So standard deviation is typically denoted with just a little s. And what you need to know is bigger values for S means data is more spread out. Okay, smaller values for S means data is much more compact. It's more tightly, like, I don't want to say it, it's more clumped together. Okay. Data is more clumped. It's not a very math word, but it'll work. More clumped together. So the data items are not as spread out. Okay. Now, as a definition, don't freak out when you see this. Standard deviation equals, first of all, we're going to be taking a square root of something big, okay? Now, we have a few symbols that we've seen before, so don't get too bent out of shape. We have that weird summation symbol, okay? So this again is the summation symbol, and it's just asking you to add them up. Them being whatever comes after the summation symbol, okay? We're also going to have just X's. X's represent the individual data items. Now, essentially what we're doing is we're looking to see how each data item differs from the mean. So we obviously have to have the mean as part of our calculation. So anytime you're looking at calculating the standard deviation by hand, first thing you have to do is calculate the mean unless it is given to you. And remember, we use X bar to denote the mean. Okay. And then we also need to know the number of data items that we have in our set. So we use n, lowercase n, to represent the number of data items. So here's what we do. We take each data item, we subtract the mean, and then we add all of, well, let me back up 1 second. We take each data item, we subtract the mean, and then we square it, okay? And then we add all of those up, and then we divide by the number of data items minus 1. Don't ask about this. It has something to do with degrees of freedom. I haven't dealt with degrees of freedom in 1,000 years. It's beyond the scope of what we need to know. So just know how to use the formula and then understand this right here, okay? But don't get too bent out of shape about the details of the formula, okay? So again, you take each data item, subtract the mean, square it, add them up, divide by n minus 1, and then you take the square root of the whole thing, okay? So the first thing you do is calculate your mean. You then take each data item individually, subtract the mean, square the result, add all of those up, divide by n minus 1, and then the very last step is to take the square root of all of that, okay? So I've got some of this listed out here at the bottom, right here, but I thought it would be easier if I wrote it out as you go so you can take notes with it, okay? So that is the formula for the standard deviation, and I think we need to just kind of dive in and do this. And I promise I will show you how to do this on your calculator and on Desmos. You can do it on Desmos as well. So example 2 here, it says find the standard deviation of the following data set by hand, round to 2 decimal places. So if it says do this by hand, you've got a lot of work you have to show. None of the work is terribly difficult, it's just tedious, okay? So the first thing we need to do is we need to find the mean of our data set. And remember, if you're calculating the mean of a data set, you add up all of the items in the data set and then divide by the number of items in the data set. So our data set has 75, 92, 83, 86, and 79. And that is 1, 2, 3, 4, 5 data items. And then I'm just going to use the handheld calculator for now. I'll show you how to do this stuff on the calculator too, but for now we're just going to do the basic calculations on our like our handheld. So let's see here. I need to add the numerator, so I've got 75 plus 92 plus 83 plus 86 plus 79. I get 415. I then divide everything by 5. And I get that the mean is 83. We need to use that. The mean is part of our calculation, okay? So here's what I find is easiest. I think it is easiest to organize your work when you're finding standard deviation if you create a little table, okay? So we're going to make note of our data items. We have 75, 92, 83, 86, and I need to scroll down just a tiny bit more, and 79. Remember, our mean is 83. So what we're going to do is we're going to take each data item and subtract the mean. So I get 75 minus 8. So 75 minus 8 is going to be 5, minus 83, excuse me, is going to be negative 8. I then take 92 and subtract 83. That's going to be what, 9? 83 minus 83 is 0. And then 86 minus 83 is 3. And then 79 minus 83 is what? Negative 4. I think that looks good. That's what I got when I worked this out on paper as well. And now we want to take each of these results and then square them. So negative 8 squared, make sure you put it in parentheses, is 64. 9 squared is 81. 0 squared is 0. 3 squared is 9. And negative 4 squared is 16. And then the things that we're going to be adding up will be all of this that I'm about to highlight. We need to add up this whole list. So we want to add, and let's see what we get here. I get 64 plus 81 plus 0 plus 9 plus 16, and I get 170. Okay. Now remember, the formula for the standard deviation is the square root of the sum of the x's, that's just the data items, minus the mean squared. So we're going to take each data item, subtract the mean, square it, then we're going to add those up. Then we're going to divide by n minus 1. Well, in this case, n is just 5. We had 5 data items. So what we're going to do is we're going to take the sum of all of that stuff, which we have now found to be 170. We're going to divide it by 5 minus 1. Remember, n is 5. We want to divide by n minus 1, so we're going to divide by 4. And then we'll take the square root of all of that. So we can type this into our calculator all at once. And I think for this one, I will go over to the screen. So let's go here. Whoops, I forgot to sign in. It'll just take a second. It's pretty quick. Okay. So we want to take the square root. Now, if you're unfamiliar with how to do a square root on the TI-83 or TI-84, you want to hit the second button, and then 2 buttons below, or well, 3 buttons below the alpha button is the square root button. So we want to go second, and then this x squared button has a little square root in the corner. So square root. And then we had 170 divided by 4. And then let's go 2 decimal places, okay? So if we were to round this 2 decimal places, we would get 6.52, okay? So the standard deviation here is 6.52. So we get approximately 6.52. So it is definitely a process. I would never expect you to do this by hand with more than like maybe 10 or so data items. If you get to the point where you have 15, 20, 50, 60, 100 data items, doing this by hand would be really quite tedious, okay? Now, as for using the calculator and Desmos, okay, you have to have your data set, so we have to have these data items right here, but your calculator and Desmos can calculate the mean and the standard deviation for you. So let me show you how to do this on the calculator first. So if we go to the calculator, The last video, not the last video, but the last worksheet, I showed you how to use this stat button on your calculator. So if you have a TI-83, TI-84, there should be a stat button that is a couple of buttons to the right of the green alpha. So you hit stat. The stat button has three menus. It has an edit menu, a calculate menu, and a tests menu. We need to use edit for now. We want to input a list of data. So the edit menu should be highlighted, and we want to choose option 1 under edit, which is edit. Okay. Now, if you have old data in there, you need to clear out the list. And here's how you clear out the list. You want to hit the up arrow, just use your left, right, up, down arrow buttons. We want to hit the up arrow button until, in my case, L1 is highlighted. And then all you have to do is hit clear. It at first doesn't look like anything happens, but once you go back down into your list, everything will disappear. Okay, so you want to make sure your list is empty. And then we want to input our data items, which were 75, so 75 and then enter, 92 enter, 83 enter, 86 enter, and 79 enter. So make sure you've got your data items in there, double check to make sure you don't have any typos. So 75, 92, 83, 86, and 79. I think mine look good. And then we immediately hit stat again. Okay, so we're going to hit stat. And this time we need to calculate something. So we want to hit the right arrow until the calculate menu is highlighted. And then under the calculate menu, we want to choose again just option 1. Okay, this is one var stats or one variable statistics. And then make sure the list here is going to match the list that you chose. So if I go back to my list where I edited, I put everything in L1. I need to make sure when I go to calculate that it says L1. If not, you need to change that, okay? And the way you change it, if I wanted to change this, notice the just the number buttons on your calculator. We have 1, 2, 3, 4, 5, and 6. They have an L1, an L2, an L3, L4, L5, and L6 in blue. That means if I wanted to change this to L2, I could just go second and then hit the 2 button and it'll change it to L2. But I don't want it to do L2 because I put my data in list 1, so L1. So I'm going to change that back to list 1. Well, we're going to clear that out first, and then we're going to change it to L1. And then don't worry about anything, just hit enter until it calculates. And it shows us quite a few things. So it's going to calculate a lot of things all at once. The very first thing is the mean. So X bar, remember, is our mean, and it is 83, which is exactly what we got when we did this by hand. When you see this next symbol here, it says summation symbol and then X, that's just going to add up your data items. And then summation symbol X squared, it takes all the data items, squares them, and then adds them up. We don't need that. SX is the standard deviation. And notice we get 6.51, blah, blah, blah. If we round 2 decimal places, we get 6.52, okay? This symbol here, it's for something I think called variance. Don't worry about it. We don't need to worry about it. And then N equals 5 tells us how many data items we have. Min X tells us the smallest data item. Don't worry about Q1. We're not going to deal with that. And then next we have the median, which is 83. We don't need that here, but it is something we calculated in the previous worksheet. Don't worry about Q3. We don't need to worry about that in this class. And then finally, max X tells you the largest data item in your set. For this worksheet, the most important data items here, or not data items, but the most important calculations are going to be X bar and SX. That is the mean and the standard deviation, okay? Now, if we wanted to, we could share, actually, let me go back. I'm going to go back and do Desmos, I think. I'll go ahead and show you that. Okay, in Desmos, you can get it to calculate the mean and the standard deviation as well, okay? So we want to open up the graphing calculator like normal. And right here, what I'm going to do is I'm going to type the word mean. And then in parentheses, I'm going to type out my data items just with a comma separating them. So we had 75, comma, 92, comma, 83, comma, 86, comma, 79. And make sure your data is, your like list of data items are in parentheses. And then just, you can see it's calculating it down here in the corner. So again, it calculates our mean as 83. Now for standard deviation, what you want to type in is STDEV, just like that. And then same thing, you can either copy and paste or type in your list again. 83, 86, 79. And again, as you're typing it in, it calculates your standard deviation, which one more time we get 6.52. So if you do not have the graphing calculator, but you do have access to Desmos, you can still do the mean and the standard deviation. Okay. Now, if directions on an assignment for me say by hand, I want to see your work. Okay. You could certainly use Desmos or your calculator to check your work. If I don't specifically say by hand, calculator's fair game. Okay. Let's do a couple more. And for the last well, yeah, let's just use the calculator for these. Please, please, please go back and review how to do this by hand, but for these two, I think we'll just use the calculator, okay? So example 3 here says, find the standard deviation of each data set. What do you notice, okay? So for part A, we have 73, 75, 77, 79, 81, and 83. First thing I want to do is use the calculator to calculate X bar. Then I'm going to use the calculator to calculate the standard deviation. So I'll do this on the calculator and on Desmos, okay? So if we go to the calculator, I want to go back to stat, okay? And I want to do something in the edit list. I need to edit my list of data. So under the edit menu, I want to choose option 1 for edit. I need to clear out my old list. So I'm going to go up until L1 is highlighted, hit the clear button, and then go down. And then I'm just going to type in my new data items. So for example 3, part A, we have 73, 75, 77, 79, 81, and then 83. Okay, double check your list. Always make sure you typed everything in correctly. Okay, it just takes a second and you can have just a simple typo and it's going to throw everything off. So it's worth taking a second just to double check your numbers. So 73, 75, 77, 79, 81, 83, we're good. Go back to stat. We're going to go over to calculate. Under the calculate menu, we want to do 1var stats. So hit enter. Make sure the list matches the list you actually typed your data in, and then hit enter, enter. And what we see here, let me write this down. We have that our mean is 78, okay? We have our standard deviation, let's go 2 decimal places again, is 3.74. Okay, we don't really need the other data items. It shows that we have 6 data items. It shows that the smallest was 73. It shows the median is 78. The highest data item is 83. But what we're really interested in for this particular worksheet is the X bar value, that's the mean, and SX, which is the standard deviation. Okay, so let's go back to the worksheet. And X bar we got was 78. The standard deviation was 3.74. And then just for fun, let's do the range. So remember, the range is the highest minus the lowest. So that would be 83 minus 73. So for this example, the range is 10. Okay. Now let's do this again on the calculator for part B, and then after I do part B, we'll go back and do both of them on Desmos just to double check and make sure you know how to do that. So for part B, we have 40, 44, 92, 94, 98, and 100, okay? We are again going to look at X bar, the standard deviation, and then just for fun, we can do the range again. My highest data item is 100. My lowest data item is 40. So my range is 100 minus 40, or 60. So you can see that's a pretty high range. These data items are fairly spread out, okay? Especially when you compare it to the data set in part A. We had a range of only 10, so those are much less spread out compared to the second data set. All right, let's go back to the calculator. All right, I'm going to go back to stat, okay? I'm going to edit my list. You could technically do another list in L2 and then kind of compare the two side by side, but I'm just going to show you this one method so as not to super confuse. We're going to go up until L1 is highlighted, hit clear, go back down, and then I'm going to type in my new data set, which is 40, 44, 92, 94, 98, and 100. Okay, and then again, just take a couple of seconds and double check. It's very easy to put in a little typo in your calculator. It's worth a few extra seconds to just double check. So 40, 44, 92, 94, 98, 100. Mine looks good. Okay, so we want to go right back to the stat button. So we're going to go stat, and this time we want to calculate something. So I'm going to go to the right and get the menu for calculate, and we want to choose one var statistics, so one variable statistics. Now, if you did have a list in L1 and L2, you could do two variable statistics and it'll calculate some of those same calculations for both lists at the same time. We're just going to do one var stats though. My list is in L1. Hit enter. And notice here, I get an X bar of 78. So this data set, even though the range was 60 compared to 10 in the other data set, I got a mean or an average value of 78 again. So X bar is actually the same for both data sets. But this time, SX, the standard deviation, is 28.06 if we round two decimal places. Okay, so let's go back. All right, so X bar for data set in part B was 78, and then the standard deviation was 28.06. Okay, so both data sets, when it says here, what do you notice? What I notice is that both data sets have the same mean. This is very similar to that example at the beginning where we had city A and city B. They both have an average annual temperature of 75. However, city A, the temperatures were spread from about 40 to 100, whereas city B, the temperatures were spread from more like 60 to 90. Okay, so even though the annual temperature made the two cities look the same, when you get down to the details, the two cities had wildly different temperatures throughout the year. That's kind of what's happening here. We have two data sets that have the exact same mean. But just at a quick glance, we can see looking at the range that even though the mean is the same for these two data sets, the data are spread out very differently. In example A, the data points are very compact. They're pretty close to each other. They only have a range from high to low of 10 versus part B where they are not compact. They're really quite spread out. We have a couple of data items in the 40s, and then we have 4 data items that are 92 and above. So there's a lot of spread here between the highest and lowest. And you can also see that in the standard deviation. For example A, the standard deviation is 3.7 versus the standard deviation for example B or part B, where the standard deviation was 28. Okay, so you can see here by the standard deviation, that's telling us kind of on average how much the data items are differing from the mean. So you can see here there's much more spread in the data set in part B than part A. Okay, so if you ever had a question like, what do you notice? Explain all those different things. In this case, we can talk about the range because we end up calculating the range. We can talk about the mean and the standard deviation. Same mean, different standard deviations. The data is spread out very differently. Okay, now really quickly before I end this video, let's go back and just make sure we know how to do this in Desmos. Okay, so I think it's this, yeah. All right, let's actually get rid of those two. We don't need them. All right, remember to calculate the mean, all you have to do is type the word mean and then start a set of parentheses and then just type in your data set, separating each number with a comma. And you can see here it told us that the mean is 78. And then what I'm going to do is I'm just going to copy this. And then for standard deviation, it's STDEV, parentheses, data set parentheses, and then it'll calculate your standard deviation. So you can see we got a mean of 78 and a standard deviation of 3.74. We'll do the same thing, but for our second data set, we had data items of 40, 44, 92, 94, 98, and 100. And you can see the mean is 78 again. And then I'm just going to copy and then STDEV. And you can see here our standard deviation is 28.06. So if you don't have the graphing calculator, you can still do this with Desmos. You can get the Desmos test app and you can use that on the tests. Okay, so there you have it. That is measures of dispersion. All right, Desmos you can use for mean and standard deviation. The calculator, mean, standard deviation, it'll also do the median. I don't know if Desmos does the median. But you've got options here. You can definitely use technology to help out quite a bit with this section and the previous section on measures of central tendency. In the next two sections, we're going to talk about something called the normal distribution.